Okay. Hi and welcome. This is introduction to GraphQL, designing your own API. Our purpose today is to understand the key differences between REST and GraphQL. Obviously, also learn what it is. We're gonna go through designing a very basic GraphQL schema, and then how to implement queries and mutations in GraphQL. However, we're not going to go too much into details and coding. There will be some recommendations, though, where to go next from this. GraphQL is a query language for APIs and also a runtime for executing those queries. It uses a pretty strict type system that you define your data with. And you can say that it is one of the newer developments. REST that we also go through is originated from 2000, and RPC and the version of more recently used gRPC is an even older technique. SOAP is almost dying out, however, is still used in some legacy systems. So why did GraphQL emerge? It started at Facebook, now Meta, in 2011, 2012, and mainly because their front end evolved very quickly, developed very quickly, and creating a new REST endpoints for each request was essentially too much work. They also started developing different versions of front end for different platforms, which had very different needs. Mobile app and Facebook started looking very different from the desktop, and the scale of this platform has expanded enormously. So the demands on performance have increased. So they basically just decided to develop their own way to write APIs. In a few years later, GraphQL was moved to the newly established GraphQL Foundation has been released as open source, the whole specification, and since then it's been Linux Foundation who is financing development of GraphQL, and it's an enormous open source community that surrounds this technique. So today, GraphQL is used extremely widely. So you've seen that GitLab provides GraphQL public API that you have used, Twitter now, X, Airbnb, Facebook obviously still using it, Shopify. Many large platforms use GraphQL today. It's becoming almost a new standard for making public APIs available. And then, of course, for communication between microservices, it's also widely used. It's a, as I said, thriving open source ecosystem, and there are a bunch of add-on tools that various degree of free and open source or proprietary that are available on top of it. It is production ready and scalable. So since the purpose of designing it was so it scales, it is really built in, and there are a lot of libraries available that make it easy to deploy this type of APIs, and scaling comes naturally. And another thing is that it empowers front-end developers. You can you have much more freedom in developing interfaces and much more control over what data you fetch from the backend. So I don't know how else to sell this to you, but basically from this year, GraphQL is added to our course on Web as Application Platform, because I think it is extremely important that you understand the differences and that you have at least tried to develop your own GraphQL API. So we go forward. So why GraphQL? Is it a replacement for REST? What are advantages or disadvantages? I encourage you to now, through this video, and then when you read the other materials, to reflect on if it really is a replacement for REST, or is it just there are two different approaches that are good at different things. If we go through the positive, then first is that, as I said, you fetch only what you need, no overfetching or underfetching. So you have a much more freedom to specify in GraphQL requests what you're getting to the front end, so which saves on the bandwidth that is used. There is a strong typing and schema. So instead of endpoints, you basically just describe your data, and a lot of verification, security issues and design issues are solved by just creating a strongly typed schema of the data. So instead of focusing on the requests, we're focusing on data, on resources first, and then the endpoints come automatically from that. There is no endpoint design in GraphQL like there is in REST. There is a single endpoint that aggregates all the data. It doesn't mean that we don't have any challenges in designing an API, because we still have the same way of thinking. So if you have worked with REST, it will definitely help you to design a good GraphQL API as well, and you will see where. So benefits then: efficient in data fetching, more accurate results, more control over the types of the data that is returned or sent, then if it's a modification. Reduces errors both in fetching and in mutations, like when you need to change the data. And this is what also, all of this makes it very suitable for managing complex microservices. So here is a hint where to use GraphQL and when to use REST. Maybe you start seeing it. Here's another comparison. As a fun illustration from one of my favorite technical newsletters. If you haven't signed up for it yet, please do. Byte Go, very nice system design, best practices, illustrations, articles. Comes about once a week. Hugely, to a large extent, it's free. And then there is some premium features, but this is where I've been taking this from. You can see how the request in REST or GraphQL looks like. So in REST, we send it the direct request to a microservice that is supposed to handle it. The server executes this function and returns the result. And GraphQL then is sort of like a middle layer, since it's a runtime, so you can see it as another microservice layer that handles the request in slightly different way. It organizes all the resources in a graph. Here's where the name comes from. So it's a graph query language. So we will see how we can think of our resources as a graph instead. So if in the REST we have been dividing our resources in then thinking what is a collection, what is an object, what is a document, right? And then out of that, putting the resource in the center. We have a resource user. Here is our endpoint users. Here instead, the user will be just a node in a graph, and it can be connected to other things. And when I fetch data, I maybe for my interface, I want to fetch both the user and its orders in one neatly defined JSON object instead of doing multiple requests to my server. So here is the main difference. GraphQL also validates the requests in a completely different way, again, because we have strictly defined schema. So instead of maybe error handling with a lot of if statements, or I mean, it's still some of this thinking already comes to REST, especially if you, for instance, tried Python and or some other strictly typed approach of Python Fast API, for instance, also has this strictly typed defined schema for REST APIs that is used to validate requests. So it exists, but it doesn't come by design. But here we have we have it built in GraphQL. And then it assembles the data into JSON response that the different front ends can accept. Another thing is that in GraphQL there are subscriptions to like schema modifications, and that allow for much easier asynchronous fetching. We're not going to go through this in this course, but it is very useful to keep in mind for your future endeavors and for cloud native applications when you are required to use asynchronous communication with your microservice. Then when we look at this, what could be the disadvantages of GraphQL? And there are one of them comes from the advantage. So you say, yes, we don't fetch things that we don't need, and so on. However, depending on the front end code and how you consume or how you design your graph as well, there can be problems with overfetching. If this is important to keep in mind. Another thing is increased complexity. Sometimes it can be difficult to understand this schema and how it corresponds to your data in the database, to map everything, and when the schema is modified, how to modify the front end code. It can be difficult to understand how the query should look like, especially if there is not enough documentation or examples. Let's say the GraphQL is less intuitive, and then you maybe already noticed this when you were consuming it, and you might sit there with a lot of question marks in your head when you try to implement something as well. But as I said, it is a very important technique for scalable web applications, so we're going to get through it together. If we go further than to side-by-side comparisons with REST, here we see how in a very simple case we're getting user information and an address from a API. This might be not very restful. Maybe we assume that we only have one user. So that's a different problem. But normally we need to get a different a different endpoint, maybe not for address, but if we have orders like in the previous example. And then there is a fixed amount of fields that is returned. How in REST can you actually make this customizable? Yeah, you can have some kind of flag here, like and return address, for instance, from here, and handle it in the backend. But in practice, it's there is no standardized way of doing that, and you often end up with a lot of with multiple requests to the server. So here, what we do is we can just specify exactly which fields we need, and we can nest our relationships if they're connected in the graph. And we have only one one endpoint, and as long as we understood the structure behind it, we can easily define the queries when we consume the GraphQL. In terms of endpoints, again, for in REST, we're used to this HTTP standard. We get, we post, or we put patch delete when we update or delete the data. We don't have any watching capabilities, so that needs to be implemented by external tools. In GraphQL, there is a different lingo for all of these things. You just have a query. And it can look in different ways. However, a query can also send a mutation to your backend, and in this way, you specify how you want to modify your data. So if in REST, each endpoint returns a fixed set of data regardless of the client needs, GraphQL you specify. In GraphQL, use a single endpoint, allowing clients to request exactly what you need, and a query specify the data structure. And then for mutations, you also specify that in the query. Easy. So how do we start designing our own API then? Once you have picked your the topic, your data set for your API, you start maybe with sketching your relationships with the data. And this looks very similar to the way you design a database. So you have objects, you define your resources, again, the same as with the rest. And then you start with specifying relationships. So is it one-to-one? Is it one-to-many? Okay, user has several posts several comments. Posts can belong to a category. So here's how your first sketch can look like. Then you can define how clients would want to request the data, so what fields this entities would have, and which of these we need to modify. So in the assignment that you will make, your goal is to define at least one entity that will be created, updated, and deleted. So like the full functionality. So for this, if it will be users, if it will be posts, doesn't really matter, right? What we go to next, right, is that this is how it can look as an example, right? So user one can have several posts. As I said, posts can belong to different categories. Each post has a title, the text, the date published, author. So here we start with specifying. This can be on paper. You can start writing it in a code. You can start brainstorming it with generative AI, specifying I need this in my app, right? Then you link it in a graph, and link in a graph again means a relationship, basically very similar to your relationship in a database. So if you already have designed a database, you put things in your database, making a GraphQL schema for it is not going to be that difficult. Another thing is that you need to consider is the UI requirements, right? So what do you want to display? Then if you don't need something to be displayed or returned, then we don't implement it in the moment in our schema. And then, of course, it's not a top-down process. You're not going to be able to perfectly define your schema and then just, I don't know, generate the code, everything's great. It is probably going to be an iterative process. So start with something, start with one entity, then add another, and then add relationships. And after you are able to query, then go further to mutations. But from here, then we go into scheme definition language. So for for GraphQL, then this schema, then these relationships with the data are defined in this format. Looks a little bit like a mix of JavaScript and just regular JSON, but it's basically what it is. You define your objects, they are strictly typed again. So if we have a type author, it has fields, first name is a string, and so on. So this is all very well specified in documentation and very standardized. So you define your object types. From here already, if you have written this, you should be able with either Express skeleton code or in any other language like Go or Python to basically specify your first backend code that will handle this function. So the querying of the GraphQL. Then after that, the next, if queries are working, we go to mutation types. Subscription types we're not gonna cover in this course, but mutation we will need. We will need to specify mutations on at least one of these object types. This might be the most confusing part of it, but the mutation you also specify in the schema. So you need to basically tell the both the front end and the server what things we can do with this object, and if it's a mutation, what type of mutation it is. It one of the first ones then potentially would be to add a new post. Then if we have a user, add a new post, and another one will be delete the post. Will you make a modification to a post? Maybe, right? Maybe you will have a modification to a username. So whatever our frontend needs. And then after you added mutation to the schema, you need to implement the resolver function. So what happens? What is the resolver function? This is the code in your backend that will be mapped to this mutation specification in your schema. This is how it can look like. There is a very extremely well made tutorials by Apollo. Apollo is an implementation of GraphQL. There are libraries that are open source, and then they offer for different, all possible languages, and then they offer hosting and basically the orchestrating of GraphQL. You don't need to use that. You can just deploy your GraphQL to OpenStack, but tutorials are highly recommended. So if after this video you're confused and when you look at the resources and I kind of come later you're confused, then I strongly encourage you to go to this list of tutorials from Apollo, where it step by step goes through what I just said about developing your schema, specifying mutations, resolvers, and arguments. So if you just take your code, your data that you want to develop API for, and you follow this 4 tutorials as a code along, you will have your assignment at the end. And they are JavaScript code alongs. So launch to space with Apollo. We go further then in terms of best practices that you are encouraged and required and all of this to follow in the course is that you design your schema well. It's going to be a pretty basic schema. We're not going to make any advanced APIs for large amounts of data here. So hopefully it will be straightforward. That use descriptive names for types and fields. So the same rules pretty much that have been used for decennia in REST. Basically, you name your entity to what it is, and if it's a plural, it's a plural. If it's a object here, it is going to be a singular. There are some naming conventions in general that you might have seen. So like if it's it's basically, and don't use variable 1, variable 2, right? Name things for what they are. If it's an email, that it should be named email, right? Leverage comments and descriptions for documentation. It is extremely important to document GraphQL API. In this, we don't have the same maybe Swagger and Open API standards, and how many of this is solved is by what comes next with this playground. Playground is like an interactive IDE, both when you develop your schema. It is available again for all languages. It is basically like a web app that is running. And then when you deploy your API, you make it available to your users also. So if you have consumed any type of GraphQL, you probably have seen this before, that you can just type a query and get some feedback, so interactively, and then get the data before you stick it in your front-end code. So, and people argue, but this everything is there, but you know that if you have tried it on your own, that it is often not enough, and it is confusing, and you need to document more, right? And what does it mean? Schema first is your core documentation. So this document that will have this definition should have as much information about your data as possible. So comment on what these types mean, what these entities mean, what the fields mean, and so on. So this is your first line documentation, and clear description and comments, right? Then we have interactive tools. Yes, please make it available. Leverage schema introspection and exploration. But then even on top of that, we need some kind of examples and some kind of walkthrough for everything that is possible for your user to have. I still like OpenAPI documentation for GraphQL, and there are plugins and libraries that allow you to sort of convert whatever documentation you have and kind of spit out the Swagger similar documentation that you can make available for the purpose of our course. It can also be enough with Postman, because we still define our queries there and our tests there. So all you need to do is basically write some more description, and there you go, Postman public link which describes your API through tests. That's also extremely good. Then for testing your GraphQL API, again, Postman features schema imports, so there is no problem sort of to start working with it. And here is an example for how you can start defining, just define a GraphQL query, and in the same way assert things in the tests then if you have gotten the the right data. Uh, Many people also use Apollo client instead of Postman. If you want to dive into that, go ahead. But I'm not gonna provide you more support than that. It is pretty straightforward and it's very similar to Postman. Basically, it's a client application that allows you to specify these test cases for GraphQL API. So if you're already using Apollo ecosystem, then it's a good choice. There's also GraphQL request libraries that lets you write integration tests. Then whichever goes, as long as you provide a test suite and that. It's also encouraged that it's built in the CI pipeline, or at least that there are clear instructions of how to run it on my machine or somewhere else online. So that is that. Then on top of the Apollo tutorials, then the next step would also be to look at this awesome GraphQL. This is a repository that contains a lot of examples in all sorts of languages, all sorts of libraries. Pick the one you want, and you have a starting ground for your GraphQL API. And here on the guild dev, you also have GraphQL code generation and GraphQL code inspector. Amazing tools for designing your GraphQL schema, validating it, and then generating code out of the schema. So this is a good tip and a good starting point. Hopefully now GraphQL doesn't sound so scary, and otherwise we will go through it also at our workshops. Handledningar. Yes, hopefully this was useful. If you have any questions, just hit me on Slack.